come to another different module which concentrates more on your logical reasoning. So far we have been discussing many topics where quantitative reasoning was high. That is, it involved a number of mathematical calculations and so on. But direction sense aptitude concentrates more on your logical reasoning capability. What do you mean by direction sense aptitude? It is nothing but how well you understand the directions. What are the different directions available? That is north, east, west and south, usually called as news. North, east, west and south. So these four directions are static, isn't it? Wherever you stand, in whatever position you stand, these four directions are going to be static. They do not change. They never change with respect to a person. For example, when I stand in this particular position, this is the east. When I stand in this particular position, and then also this particular direction will be the east. So these four directions, north, east, west and south, are static irrespective of the person's position or the position of the moving body. But the direction right and left changes depending upon my position. For example, when I am standing in this position, my right is to this side. When I am standing facing east, my right direction is to this side. Whereas when I am standing in this particular direction facing south, which is my right is to the west. My left is to the east. So depending upon the position of the person or the body, right and left directions may change. But north, east, west and south do not change. So in direction sense aptitude, this will be a very, very interesting concept, and it is found in many aptitude question papers. The one thing you have to remember is always understand the directions clearly. Understand the directions clearly. That is news. Whenever you solve a direction sense aptitude question, first write down in your paper, this one is north, east, south and west. Okay. Whenever you are going to solve a direction sense question, understand the directions properly by drawing this particular figure in your working sheet. This one will be your north in any working sheet that you use. This is going to be your north, this one is going to be your east, south and west. Mark the directions properly. So this is your first step. Next, understand that news does not change. That is, these four directions never change with respect to the position of the body or the person. Next, draw a pictorial representation of the given problem. Whenever a direction sense problem is given, convert that particular problem into some pictorial representation. Read the problem properly, understand what is given, and convert that particular problem into an appropriate pictorial form. So we shall see how to convert a given problem into a pictorial form. After converting to that pictorial form, mark the starting and ending points clearly. Mark starting and ending points clearly. Similarly, mark your arrows. Mark directions. Mark directions properly. Get some geometric properties. Understand or get to know some geometric properties. So these are some important reminders that you should keep in your mind while solving a direction sense question. The first thing, understand the directions properly. These directions do not change. Given the problem statement, convert it into a pictorial representation. We shall see. Mark the starting and ending points clearly. We shall see that in a particular problem. mark the directions properly, understand the geometric properties. So I'll tell you why these steps are important by solving out our first problem. So here is a direction sense problem. Ramesh, starting from a fixed point, goes 15 kilometers north, and then after turning to his right he goes 15 kilometers. Then he goes 10, 15 and 15 kilometers after turning to his left each time. How far is he from a starting point? So a problem is given. A person Ramesh is going in some different directions and the measurements are given. The first step in solving a direction sense question is, as we have learned, understand the directions properly. So the first thing you should do is mark the directions: north, east, west, south. Understand the directions clearly. These directions do not change. Now, Ramesh is starting from a fixed point. So, as I said in the tip, mark the starting point and the ending point clearly. So, mark the starting point. So, this is your starting point. So, Ramesh, he is starting from a fixed point and goes 15 kilometers north. That is, he goes 15 kilometers north. See, north means going this side. With regard to this diagram, mark the position. Ramesh is starting from a fixed point. He is going 15 kilometers towards north in this direction. That's why I said mark the starting point clearly. Mark the direction very clearly. That is direction of the arrows. He is moving 15 kilometers north. So mark the direction appropriate. And then after turning to his right. So now Ramesh is here. Okay. So Ramesh, in this particular position, he moved to north. Now standing here as it is, then after turning to his right. When a person moves from this position to north 15 kilometers, which will be his right, this side will be his right. From right he is moving 15 kilometers. Okay. So this is 15 kilometers and he is turning to his right. He will be in this position. He will turn to his right and then moves 15 kilometers. Now, as I said in the introduction session, mark the directions properly, mark the measurements. See, 15 kilometers is this particular line. So draw a line similar to this, which looks appropriately similar. 15 kilometers, 15 kilometers. Next. Then he goes 10 kilometer, 15 kilometer and 15 kilometer after turning to his left each time. So from this thing it is very clear, news direction is static, irrespective of the moving object's position. But the left and the right will change with respect to the position of the person. So now he is in this position. The person Ramesh is in this position, which will be his left. From here, this will be his left. Each time he will move to his left. So let us see. So Ramesh is moving 15 kilometers north. Then from here he turns to his right. This is 15 kilometers. From here he is turning to his left each time. First time he turns to his left 10 kilometers. Then from here, which is left, this is left. He turns 15 kilometers. 15 kilometers. See, mark the measurements appropriately so that it is easy to solve. 15 kilometer line, this line must be similar to this line. From this position, now just imagine from this position which is left, this one is left. He is moving once again 15 kilometer. See, you can mark till here. Okay, 15 kilometer. So Ramesh started moving towards north 15 kilometer, to his right 15 kilometer, from this position to the left 10 kilometer, from this position he moved left to the 15 kilometer. From that particular position he is standing facing towards west. He is moving 15 kilometer left. Okay. Now as I have said in the introduction session, first we understood the directions clearly. You have converted the problem statement into pictorial representation. You have marked the starting and ending points clearly. You have marked the measurements appropriately. See, 10 kilometer is equal to 10 kilometer, 15, 15, and this complete line is 15 kilometer. So only by converting your problem into this form, direction sense questions can be easily solved using your logic and simple mathematical calculation. So what I said may be a long process, but it is a simple thing. If you convert this problem into a simple format, you can easily find out the answer. What you are asked to find: how far is Ramesh from his starting point? Ramesh's starting point was here. How far is Ramesh from the starting? This is his starting point, this is his ending point. Now Ramesh started from here, went through like this, at last now he is here. What is the distance? You are asked to find this distance. You don't need any calculation. It is very clear that this is 10 kilometer, so this line must be 10 kilometer. After 10, what is the remaining distance? This is 5 kilometers, because the total distance is 15 kilometer. Now if this is 5, what is the distance? This is 10, because 10 plus 5 is total is 15 kilometer. So Ramesh is 10 kilometer distant from his starting point. Okay. So once again we'll start from the first process so that you get this particular thing clearly. Once you get this concept how to change the problem into pictorial representation, all the direction sense problems are going to be similar and easier. So start the marking point properly. This is the starting point of Ramesh. Starting point. He is moving 15 kilometer north. From here he is turning 15 kilometer right. From here 10 kilometer left. From here 15 kilometer left. Similarly 15. From here he is moving 15 kilometer left. So this totally it is 15, isn't it? You are asked to find, this is the ending point. Now Ramesh is here. So what is the distance between his starting point and ending point? This is 15. So this is 15, this is 10. So this must be 5. Now this total distance is 15. So this must be 10. The answer is simply 10. So just by visualizing you can get the answer. So here's another problem. Sonalika goes 12 km towards north from a fixed point, and then she goes 8 km towards south from there. In the end she goes 3 km east. How far and in what direction is she from her starting point? So what is the first step for solving this problem? Mark the directions properly. East, north, west, south. Okay. She is going 12 km towards north from a starting point. So mark the starting point. From here she is going 12 km. Say, okay, let this be 12 kilometers. Fine. So from the starting point, Sonalika is moving 12 km north. From here she comes 8 km south. Say here. Okay. 8 km. 8 km south. From this point she goes 3 km east along this direction. She goes 3 km. Fine. So this is the ending point. 3 km east. If this is 12 km, This is 8 kilometer. What will be the distance here? 4 kilometer. You are asked to find how far and in what direction is she from a starting point. You need to find the distance between the starting point and the ending point. That is this distance. Isn't it? So what is the value of this thing? That's what I said in the introduction session. You need to understand some geometrical properties. Visualize this. It is a right-angled triangle. Isn't it or not? This is a right-angled triangle. See? This is a right-angled triangle. And the values of two sides are given, 3 and 4. You are asked to find the length of the hypotenuse. Isn't it? So the unknown value is nothing but the hypotenuse side of the right-angled triangle. You need to know the Pythagoras theorem. That's why I said in direction sense question, you should know the geometrical properties to some extent, not very much. You need to know the properties of triangle, rectangle, right-angled triangle, parallelogram. So these, the properties of such figures. What is the property of a square? All the four sides will be equal. The diagonals will be equal. What is the properties of the rectangle? Two sides will be equal. What is the properties of the parallelogram? Opposite sides will be equal. And for a right angle triangle, what is the Pythagoras theorem? Pythagoras theorem says that the square of the sum of the squares of the two sides is equal to the square of the hypotenuse side. So let the distance between the starting and the ending point be x. By Pythagoras theorem, x square is equal to 3 square plus 4 square. That is 9 plus 16. That is 25. X square is equal to 25. So what is x? 5. So Sonalika is 5 kilometer far away from her starting point. So you got answer for your first question. How far is she? She is 5 kilometer. Okay. 5 kilometer in which direction? From her starting point, is she 5 kilometer north? Is she 5 kilometer east? Is she 5 kilometer south? So how to find out? See, she is in this direction. Isn't it? This is north. This is east. And what is this direction? This is northeast direction. Fine. So Sonalika is 5 kilometer northeast. She is 5 kilometer far away from her starting point in the northeast direction. Got it? So this is the way to solve such problems. So a simple knowledge of geometrical properties, then understanding the things very clearly in the pictorial form. So I marked upon the north and east. So I was easily able to find out that this is a right angled triangle. Using the Pythagoras theorem, you can find this value, and I understood that this direction must be northeast. So she is 5 kilometer northeast. So in this particular problem, Kanchan goes 5 kilometer east from a fixed point AB and then 35 kilometer after turning to her left. Again she goes 10 kilometer after turning to her right. After this she goes 35 kilometer turning to her right. How far is she from AB? So the first step is east, north, west. So Kanchan goes 5 kilometer east from a fixed point AB. Let this be the fixed point AB. From here he goes 5 kilometer east. Okay. So 5 kilometer east. 35 kilometer to her left. Kanchan is in this particular position. So which will be his left? This will be his left. So 35 kilometer left. 35 kilometer left. Okay. After turning to her left. Again she goes 10 kilometer after turning to her right. Now Kanchan is in this position. Which will be his right? This will be his right. So then she goes 10 kilometer after turning to her right. Kanchan is in this position. So now which is her right? This is her right. She goes 10 kilometer right. After this she goes 35 kilometer turning to her right. Now she is in this position. Which will be her right? This will be her right. 35 kilometer. This is also 35. So exactly you can draw. This is also 35. So this is her ending point. Fine. Now how far is she from AB? From AB you need to find this distance. If this is 5, what is this distance? 35. This is also 35. So opposite sides are equal. If these two is 35, this must be 10. It looks like a rectangle, isn't it? Yes. So what is this length? 5 plus 10. From AB to ending point, what is the distance? 5 plus 10, so 15 kilometer. So she is 15 kilometer far away from the starting point. Simple problem. Follow the steps which we have discussed in the introduction section and you will automatically get the answer. So Kanchan is 15 kilometer far away from her starting point. 5 plus 10, 15. It is a rectangle. Opposite sides are equal. So this also should be 10. So Manish goes southeast from his home, 7 kilometers southeast from his home. Then he goes 14 kilometers turning to west. After this he goes 7 kilometers northwest and in the end he goes 9 kilometers towards east. As I said, you should be very clear with 4 directions: north, east, west and south. So which is northeast? In between north and east, northeast. And this is southeast. This is northwest and this is southwest. So let us take a fixed point. Manish, let his home be situated at the origin. Let us take like this. This is Manish house. So Manish goes 7 kilometers southeast from his home. Which is southeast direction? In between south and east. Exactly diagonal. Exactly diagonal. So Manish from his home he goes 7 kilometers. Okay. 7 kilometers southeast. 7 kilometers southeast. Okay. 7 kilometers southeast. If you want, you can take more meters. Okay. Now, then he goes 14 kilometers turning to west. As I said, right and left directions will change depending upon the position of the person. But north, east, south, west will never change. Now he is in this position. He goes 14 kilometers towards west. So where is the west? West is in this direction. It will not change. So from here he will directly go 14 kilometers. Okay. 14 kilometers west. After this he goes 7 kilometers northwest. And in the end, after this he goes 7 kilometers northwest. Listen very carefully. So he is in this position. Now where is the northwest direction? Northwest is lying here. So this is the northwest direction. Okay. So from here he is going 7 kilometers northwest. Now you should not try to draw a line straight away like this, saying that you are reaching the northwest line. Even this is northwest, isn't it? Actually, by drawing this line, you mean that even this is northwest, but it is not so. See, if that Manish is going to this particular position, why should I say that he is moving 7 kilometers northwest? I can say he is moving 7 kilometers north. Instead of saying that he is moving northwest, I can clearly say that Manish is moving 7 kilometers north. But they have clearly given after this he goes 7 kilometers northwest. That means you should not draw the line straight away like this. Instead, take the northwest position. So 7 kilometers. I hope you got this point clearly. That is, Manish is starting from his home 7 kilometers southeast. From here 14 kilometers west. From here, where is northwest situated? Whenever I am standing like this, northwest is situated somewhere here. Do not draw the 7 kilometer line straightly, because if it is so, they would have given clearly in the question that it is 7 kilometer north. They have given 7 kilometer northwest. So take a slanting route towards northwest, 7 kilometer northwest. Then he goes 9 kilometer towards east. Where is the east? Here. So go 9 kilometer east. This is your ending point. How far from his house is Manish? Now visualize, analyze the final picture very clearly. It looks like a parallelogram, isn't it? It looks like a parallelogram. Opposite sides are equal. It looks like a parallelogram. By logic, it must be a parallelogram. If opposite sides are equal, if this is 14, this should also be 14 kilometer. If this is 9, this must be 5. 9 plus 5, 14. So what is the distance between the starting point and ending point? 5 kilometer. So what is the answer for your question? How far from his house Manish is? Manish is 5 kilometer from his house. So answer is 5 km. So direction sense questions can be solved only by clearly transforming it into a suitable pictorial representation where you use your logical sense to understand which is northwest, which is left, which is right, logically, just not simply proceeding with some rigid concepts, but in the otherwise you should know which is northwest in that particular position. So getting a clear picture of the problem statement is very important in direction sense question. Once you get that, there is no mathematical calculations involved. Simple steps, you can get the answers if you have some knowledge about the geometrical properties. So that's it. So we have covered all the types of direction sense questions.